Welcome to Learn Mathematics with Moni. Get your books and pen and get ready to learn.
You're welcome to class. Today we are looking at inverse variations. Inverse variations describe relationship where as one quantity rises, the other falls, and as the other rises, the first one falls. We can see this kind of situation in the speed of a car. If a car is running at a speed of 30 kilometers per hour, it is going to spend a longer time. Let's look at it. If a car runs at 30 kilometers per hour and spends 10 hours on the road, by the time the car travels at a speed of 50 kilometers per hour, it's going to spend lesser time, let's say 8 hours on the road. It's just like when you are walking. If it takes you 10 hours to reach a certain place when you are walking, by the time you start jogging or running, you see that your speed has increased and the time you are going to spend on that journey is going to reduce appreciably. So that is a kind of inverse variation situation. Speed and time at the same distance. When the distance is constant, same distance. Another situation is the number of people at a job and the number of days they spend on the job. If they are doing exactly the same type of job and it takes 15 men 7 days to complete the job, by the time you reduce the number of men on the job to 10 men, what do you think will happen? The number of days they will spend on the job, let's say for example, I'm just taking numbers I didn't calculate. This is not according to calculation. I'm just taking an arbitrary example. When you reduce the number of men on the job, the number of days they will spend on the job is going to increase. If they are doing exactly the same job. So these are situations of inverse variation. As one quantity increases, the other reduces. As you increase the number of men on the job, they spend lesser days on the job. When you increase the number of days you want them to spend on the job, then you have to reduce the number of men on the job if they are doing exactly the same job. Just like it applies to speed and time spent on a journey. Like I told you initially, if you have not watched my video on introduction to variation and direct variation, make sure you locate it in among my videos and watch it. I told you earlier that this is the symbol, alpha is the symbol of variation. This is the variation symbol. And every time you try to change this variation symbol to equal to, you have to introduce a constant. Let us look at an example. X varies inversely as y. Mathematically, this means X varies inverse as y. X varies inversely as y. That is, X is inversely proportional to y. Whenever you remove the inverse, the variation symbol, you must introduce a constant. This means that X is equal to K over Y. And to get this variation constant, which is K is a variation constant. is the variation constant. To get the value of this k, which is the variation constant, you can get that by cross multiplication. When you cross multiply, you have 1 times k equals to x times y. 1 times k is k and x times y is xy. With that, you can get the value of k. Once you are able to get the value of your variation constant, then you can get the equation of the relationship. Let's look at more numerical examples. P varies inversely as Q. Mathematically, this means P is inversely variable as P. And when you have inverse variation like this, and you want to remove the variation symbol to introduce equals to, this is going to become P equals to K over Q. K is the proportionality constant or the variation constant. From the question, we are told that when P is 5, Q is 10. This means 5 equals to K over 10. I have only substituted 5 and 10 for Q, P and Q respectively in the mathematical expression. Our first question is asking us to get the variation constant. Whether there is a question that asks you to get the variation constant or not, you must get the variation constant because it is actually the key to whatever you want to solve on this question. So let us cross multiply to get the variation constant. Here I have 1 times k, which is equals to 5 times 10. 1 times k is k. 1 times k is k, and 5 times 10 is 50. K equals to 50. This is the variation constant. The second question is asking us to get the equation of the relationship. Whether you are asked or not, when you are solving a variation equation or a variation problem, you have to get the equation of the relationship. Because just as the variation constant is a key, the equation of the relationship is also the door. You are going to use the key to open. So let's get the equation of the relationship. From here we have P equals to K over Q. Now that we know that K is 50, that means P is equals to 50 over Q. This is the equation of the relationship. And this is the door through which we are going to be solving whatever problem we have on this. So let us solve the C. The C is asking us to find P when Q is 5. What is P when Q is 5? The equation of the relationship already tells us that P equals to 50 over Q. So I will just substitute into it. Now, Q is 5. What is going to be P? So P is going to be equals to 50 over 5. 50 divides 5 divides 5 once. 5 divides 50 10 times. That means P is equals to 10. When Q is 5, P is 10. Let us see another example. This is a very practical example. A man spends 3 hours if he drives at a speed of 30 km per hour. His speed is inversely proportional to time of travel. Let us express that first. I want to use S as speed and T as time of travel. We are told that his speed is inversely proportional to the time of travel. S inversely proportional or varies inversely as T means that S equals to K over T. Now we want to get K. I told you whether you are told to get K or not, you need your K as the key to solve any variation problem. We are told that when S is 30 km/h, T is 3 hours. Now let's substitute into the equation and get what our variation constant is. This means that for S, I'll put 30 equals to K over time, which is 3. To get this variation constant, I'll put this over 1 and cross multiply. This is 1 times K equals to 30 times 3. 1 times K is K, 30 times 3 is 90. So our variation constant is 90. That being said, the next thing we need to get is the door. The door on which we want to use this key. And that is the equation of the relationship. We already know that S equals to K over T. That means S is equals to 90 over T. And this is the equation of the relationship. Whatever else we are asked in the question, we have to pass through this door, this equation of the relationship, to get it. So let us see. How long will it travel? Will its travel take? How long means time. What is going to be time? If it drives at 50 km/h, if S is 50 km/h. So let's go through this door since we already have the key. So S is already given as 50, that is 50 equals to 90 over T. We are looking for T. We have to cross multiply to get this T. So this is 50 over 1. By cross multiplication, I have 1 times 90 and 50 times T. Let's start with 50 times T. 50 times T equals to 1 times 90. Divide both sides by 50. 50 divides 50 once. And here, 50 divided by 10 is 5. 90 divided by 10 is 9. So we have T equals to 1 times 9, 9 over 5. You can leave your time like that or convert it to decimal or mixed number. 9 over 5 is the same thing as 1 whole 4 over 5 hours. 9 over 5 hours, 1 whole 4 over 5 hours, or change it to decimal, which is 1.8 hours. That is the time it will take the man. Can you see the kind of proportionality there? When it drives at 30 km/h, it spends more time. When he increases his speed, he spends less time. This is only practical and logical. Let's take one more example.
You need to pause right now. Go right now and subscribe to my channel. Click on the notification button so that you can be notified anytime I drop new lesson. Thank you.
This is another practical example. The number of days spent on a job varies inversely as the number of men on the job. Let's say N is, or let's use days, D for number of days. Let the number of days be D, and let M be the number of men on the job. We have been told that D varies inversely as M. This means that D equals to K over M. Let's get K, our variation constant. We are told that it takes 10 men 18 days to finish that job. That means when M is 10, D is 18. Let's get K. This means that 18 equals to K over 10. By cross multiplication, you have 18 over 1 equals to k over 10. By the time we cross multiply, you have 1 times k equals to 18 times 10. This means k is equals to 180. That is settled. Now the equation of the relationship. D is equals to k over n. This implies that D is equals to k is 180. 180 over m. This is the equation of the relationship, the one we are passing through. Now the question is asking how many men will spend 2 days on the job. That means when D is equals to 2, find M. When D is equals to 2, find M. Let us find M. D is 2 and 180 over M. We need to get M. Let's take cross multiplication to remove the denominators. So we have 2 times M equals to 1 times 180. To get our M, we have to divide both sides by 2. So now we have M equals to 180 divided by 2, which is 90 men. So a job that takes 10 men 18 days to do will actually take 90 men 2 days to do if all men are working at the same rate. I am going to stop here for today. Make sure you take the questions on inverse variation. Don't stop here. Practice problems on inverse variation so that you can become a master of this topic. I will see you around.
Thank you for learning mathematics with Moni today. Do you know you are free to share my videos with your classmates, your colleagues, your friends, your cousins? Do that right now and be a blessing to them and to me.